In this video, we are looking at more complicated binomial expansion problems. So these aren't the straightforward, just do the binomial expansion. They've got an added element of difficulty. So the first one, the coefficient of x cubed in the expansion of 3 plus ax to the power of 6 is negative 20. Find the value of a. So we could do the whole expansion of this, the first term, the second term, the third term, and then the fourth term, which would be the one we want. Or we could skip straight to the fourth term if we know what our NCR is going to be. So we want our power, that's our n, that's a 6. So it's going to be 6, choose, and then our r is 3. We're going to have no x's for our first term, which is NC0. For x, NC1. For x squared, NC2. For x cubed, NC3. So it's 6C3. So we can find that out using the calculator, and that is 20. So that's going to be our coefficient from Pascal's triangle. So 20. And then 3. Now remember that the powers always add up to 6. So if we've got x cubed, we must have 3 cubed as well. 3 plus 3 is 6. And then ax cubed. So the powers add up to 6. For our 3's, we would have started with 3 to the power of 6. Then our second term, 3 to the power of 5. Our third term, 3 to the power of 4. And this is our fourth term, 3 cubed. So we've got, this is our x cubed term. If we do 20 times 3 cubed, which is 540, we'll get 540. It's ax cubed, ax times ax times ax. I'll write a cubed, x cubed. Now this is our term, and we know the coefficient of x cubed is negative 20. So we can say that 540 a cubed must be equal to negative 20. Now we just solve for a. So divide both sides by 540, which is a cubed is minus 1/27th, and then cube root, and we get minus a third. We can say a cubed is minus 1/27th, therefore a is minus a third. And that is our answer. One for you to try. Pause the video, give it a go. So the coefficient of x cubed in this expansion, 4 plus ax to the power of 5 this time, is negative 1280. Find the value of a. So again, we're after the fourth term. So x is to the power of 0, power of 1, power of 2, power of 3. So it's the fourth term. N is 5. So it's 5c and then 3, because it's 0 for the first term and then 1, 2, 3. So 5c3, 5 choose 3, is 10. So we're going to have 10 times 4. And remember, these powers add up to 5. So this time it's 4 squared ax cubed. 10 times 16 is 160. That's 160 a cubed x cubed. And that's equal to negative 1280 x cubed. So 160 a cubed must be equal to 1280. So negative 1280 divided by 160 is negative 8. So a cubed is negative 8. A must be the cube root of negative 8, which is negative 2. Here's another question. This time, part A, we have to do the binomial expansion. So find the first three terms in ascending powers of x in the expansion of 3 plus ax to the power of 8, where a is a non-zero constant. So 8c0, 8 choose 0 is going to be 1. 8 choose 1, 8. And then 28. So it's 1, 8, 28. The first term is going to be 1 times 3 to the power of 8. The second term is 8 times 3 to the power of 7 times ax to the power of 1. And then 28 times 3 to the power of 6 times ax squared. So just use the calculator to do the simplifying. 3 to the power of 8, 6,561. 8 times 3 to the power of 7, 17,496. And that is ax times ax. And then 28 times 3 to the power of 6, 20,412. And that's ax squared, so a squared, x squared. That's part A. So for part B, given that in the expansion we've just done, the coefficient of x squared, the number in front of the x squared, that is this, is 14 times the coefficient, the number in front of x, which is this one. So we can write that as an equation. We can say that this one, 20,412 a squared, is equal to 14 times our coefficient of x, 17,496 a. So let's use the calculator. Let's times 14 by 17,496, and then divide both sides by 20,412, and that will give us a straightforward quadratic equation. So 14 times 17,496 divided by 20,412 is 12. So a squared is equal to 12a. I know a is a non-zero constant, but just for good practice, I'm going to solve this by factorizing. So take 12a away from both sides. Factorize out an a. So a could be 0 or 12. A is non-zero. So a equals 12. One for you to try. Pause the video, give it a go. So the first three terms in ascending powers of x in the expansion of 1 plus bx to the power of 9. So 9 choose 0 is going to be 1. 9 choose 1, 9. And 9 choose 2, 36. So we've got 1, 9, 36. We have 1 times 1 to the power of 9 plus 9 times 1 to the power of 8 times bx plus 36 times 1 to the power of 7 times bx squared. So simplifying, that's 1 plus 9bx plus 36 b squared x squared. Given that the coefficient of x squared is 20 times the coefficient of x, work out the value of b. So the coefficient of x squared, 36b squared, is equal to 20 times the coefficient of x, which is 9b. So 20 times 9 is 180. Divide both sides by 36. Make it equal to 0. Factorize out the b. So again, b is a non-zero constant. So b is non-zero. So b must be equal to 5. It can't be 0. We can't have that answer. It must be the 5. The first 3 terms in the expansion of 1 plus ax to the power of 8, where a is a non-zero constant, are 1, 40x, and bx squared. Find the value of a and the value of b. So the only way to do this is going to be to do the expansion, but in terms of a. So 8c0 is, of course, going to be 1. 8c1 is 8. And 8 choose 2 is 28. So we've got 1, 8, 28. We've got 1 times 1 to the power of 8 plus 8 times 1 to the power of 7 times ax plus 28, 1 to the power of 6, ax squared. So that's 1 plus 8 ax plus 28 a squared x squared. Now let's compare these. So we've got 40x as our second term and 8a as our second term. So if 8a is equal to 40, which it must, divide both sides by 8, a must be 5. And then we've got bx squared and 28a squared x squared. So b is equal to 28 times a squared times 5 squared. 28 times 5 squared is 700. So b must be 700. One for you to try. Give this one a go. The first 3 terms in the expansion of 1 plus px to the power of 10, where p is a non-zero constant, are 1, 40x, and qx squared. Find the value of p and the value of q. So we want 10c0, 10c1, and 10c2. So that's going to be 1, 10, 45. So we've got 1, 1 to the power of 10, plus 10, 1 to the power of 9, times px, plus 45, 1 to the power of 8, times px squared. That's 1 plus 10px plus 45 p squared x squared. And let's compare. So we've got 40 equal to 10p. So p must be a 4. And q is equal to 45p squared, which is 45 times 4 squared, which is 720. And one more. When 1 plus 3x to the power of p is expanded, the coefficient of x squared is 2,700. Find the value of p. This time we don't know the power. So we want the third term of this one. We want p choose 2. And then it's going to be p choose 2. It's going to be that times 1 to the power of p minus 2 times negative 3x to the power of 2. And that is going to be equal to 2,700 x squared. So we can say 1 to the power of p minus 2, that's going to be 1. So we don't have to worry about that. PC2. Now we can't type that in the calculator. Instead, we're going to have to use the definition of our NCR. So that is NCR is equal to n factorial over r factorial times n minus r factorial. That means we've got p factorial over 2 factorial times p minus 2 factorial. And it's that times negative 3x squared. Negative 3 times negative 3 is 9. So it's 9x squared, and it's equal to 2,700 x squared. Now write the x squareds in there, but I'm just going to cross them off because we don't need them. I'll divide both sides by 9. Let's do 2,700 over 9, which is 300. So we've got p factorial over 2 factorial, which I can just change into 2, times p minus 2 factorial equals 300. Let's times both sides by 2 and get rid of the 2 factorial. So p factorial over p minus 2 factorial is equal to 600. Now, how can I solve this? So p factorial over p minus 2 factorial, I can cancel out. So when you've got 2 factorials and one's 2 less than the other one, you're going to have p times p minus 1 times p minus 2 all the way down to 3, 2, 1. And p minus 2 is going to be p minus 2 times p minus 3, and so on, all the way down to times 5, times 4, times 3, times 2, times 1. So all of those lower ones are going to cancel out. And all I've got really that's going to be left is the first 2 terms. And that is p times p minus 1. So the p minus 2's cancel out, the p minus 3's cancel out, and every following term, every following multiplication is going to cancel out. So p times p minus 1 is equal to 600. So I could just find 2 consecutive numbers that multiply to make 600. Or I could expand this and solve it. So I could just go, well, what's 14 times 15? That's 210, that's too low. What's 19 times 20? That's not big enough. So what's 24 times 25? That's 600. So I could do it like that and just say, well, p is 25, because this must be 25 times 24, and then all the rest of them cancelled out. Alternatively, so I know p is 25. Alternatively, if I expand this, p squared minus p equals 600. Take away 600 from both sides. So p squared minus p minus 600 equals 0. And then I'm going to want to factorize this. And of course, it's going to be 25 times 24 to get 600. So minus 25 plus 24. So p is 25 or negative 24. I can't have a negative So it must be 25. When 1 plus 2x to the power of p, so one for you to try. When 1 plus 2x to the power of p is expanded, the coefficient of x squared is 180. Find the value of p. So again, it's going to be p choose 2. And then we're going to have 1 to the power of p minus 2. And then 2x squared. And that is equal to 180x squared. So 1 to the power of p minus 2 equals 1. So we've got p choose 2. That's going to be p factorial over 2 factorial times p minus 2 factorial times 2 squared, which is 4, x squared equals 180 x squared. So 180 divided by 4, which is 45, times 2, which is 90. So p factorial over p minus 2 factorial is equal to 90. P minus 2's cancel, p minus 3's, p minus 4's, and so on. So we're just left with p times p minus 1 equals 90. Which two consecutive numbers multiply to make 90? 10 times 9 is 90, so therefore p must be 10.